Hello and welcome to part 1 of our Objective 1 notes. I can simplify numeric expressions using the order of operations. Now, the order of operations is probably something we're already familiar with, but we're going to go ahead and review a little bit just to make sure that we're all on the same page moving forward. So the order of operations, there's a lot of different ways people remember it. One of the most common ways is Pemdas, right? Which is listed on the side here, Pemdas. All right, now there's different ways people remember that. My favorite being, please excuse my dear Aunt Sally. But for us, we're just going to refer to it as PEMDAS, and we'll call it good from there. So what does PEMDAS stand for? PEMDAS, quite simply, stands for parentheses, then exponents, then multiply. D is for divide. A is for add. And S is subtract. Now, although that's what PEMDAS stands for, it's not really that straightforward. There's actually a lot of conversation going on in the math world about better ways to explain the order of operation. For example, parentheses. That doesn't necessarily mean if there's parentheses, that's what you do first. Parentheses just means you simplify inside parentheses first. Simplify inside the parentheses. And then multiply, divide, add, subtract. You know, down here with MDAS, the MDAS of PEMDAS, that's a little more complicated than just multiply, divide, add, subtract. Because remember, let's say I'm multiplying a number, let's say I'm doing 4 times 2. Well, that equals 8. Awesome. Now, what about 4 times 1/2? Well, that equals 2. But 4 divided by 2 also is 2. Multiplying by 1/2 is the same as dividing by 2. Multiplication and division are really the same operation. They're just looked at a little differently. So multiply and divide are really on the same level here. Same with add and subtract. Let's say I have 4 plus 2. Well, that gives me 6. But what about 4 plus negative 2? Well, that gives me 2. The same as 4 minus 2. Adding a negative is the same thing as subtracting. So adding and subtracting are on that same level as well. All right. So what's another order that is also mathematically correct? Like we just said, multiply and divide could be switched. Add and subtract could be switched. So we could say PEDMSA. Parentheses, exponent, divide, multiply, subtract, add. And that'd still be mathematically correct. Why is that order correct? Because multiplying is dividing and adding is on that same level as subtracting. Multiplying by 1/2 is the same as dividing by 2. Adding by negative 2 is the same as subtracting by 2. So now that we've gone over all of this content, all of this information, kind of good review, let's actually apply it to a little bit of math. So let's look at problem set number 1. So our notes are going to be split up into problem sets. This first set asks us just to simplify the following expressions using the order of operations. So looking at letter A, I have parentheses 18 over 3 quantity squared minus 3 times negative 2. So following my order of operations, remember parentheses, exponent, multiply, divide, add, subtract. First thing, parentheses, all right? 18 divided by 3 is 6. So this becomes 6 squared minus 3 times negative 2. Exponents, I got some exponents here. 6 to the second power is 36. minus 3 times negative 2. Multiply. All right, so 3 times negative 2 would become negative 6. So this will be 36 minus negative 6. And then add, subtract. If I'm subtracting a negative, that's the same thing as adding a positive. So this will become 36 plus 6, which will give me 42. Shout out to Jackie Robinson. 42 right there. All right. Now let's look at letter B. 11 minus 5 divided by 4 minus 2. Now this one's a little tricky because the way it's written has some implied ideas. Think about how this would be different from 11 minus 5 divided by 4 minus 2. Looking at this one on the right, I would have to do 5 divided by 4 first because division is before subtraction. However, with how this is notated, I can assume that there are parentheses around these. I need to simplify my numerator and then my denominator. So I do 11 minus 5, that's 6. 4 minus 2 is 2. 6 divided by 2 is 3. And that would be my final answer. Alright, why don't you go ahead and pause this video. I would like you guys to try letters C and D on your own. So go ahead and pause the video, do C and D, and then we'll go through those together. Okay, let's see how we did with C and D. So look in here, I see some parentheses going on. So I'm going to start with 4 plus 1 plus 2. That'll give me 7 times 6 divided by 9 minus 2 is also 7. So from here, look again, parentheses, exponent, multiply, divide, add, subtract. According to here, I should multiply and then divide. All right, so we can do that. That's fine. 7 times 6 is 42. 42 divided by 7 is 6. How'd you do? Did you also get 6? Very nice. All right. Looking at letter D, a little more complicated stuff going on here. I'm seeing right away we got some exponents inside parentheses, so let's do that first. So 4 squared is 16 times 3 minus 18 divided by 2. Now what should we do next here? Does it really matter if I multiply this or divide this first? It really doesn't, remember, because multiplying and dividing are on that same level. But we're going to go ahead and just work left to right here. So 16 times 3 is 48 minus 18 divided by 2 is 9. So now I just have 48 minus 9. Let's see, that would give me 39. Excellent. Depending on how you did on those, if you have any questions, go ahead and raise your hand and I can come around and help you out on that one individually. So hopefully we got 6 for C, 39 for D. If we did, then we're definitely ready to move on to E and F. Let's look at E and F here. I'm going to zoom in a little bit on E to give me a little more space to work because there's a lot of stuff going on here. So first I have 6 times parentheses, 5 plus 4 minus 3 plus 2 minus 1. Minus, and then I have double parentheses here. We have 1 plus 2 plus 3 plus 4 in one parentheses, and then divided by 5 in the second parentheses. So what do I need to do first here? I need to notice what parentheses I need to do. So 6, I got nothing inside of that. 5 plus 4 is 9. 9 minus 3 is 6. 6 plus 2 is 8. 8 minus 1 is 7. So let's go through that again. This becomes 9 minus 3 plus 2. Ooh, can't really do that with these order of operations. That'd be a little tricky. Let's take this a little simpler. 9 minus 3 is 6. And then I do 6 plus 2 is 8. 8 minus 1, and again we get that 7. Alright. Thank goodness I didn't do 9 minus 5 minus 1. Alright, that's where the order of operations is important. Just go left to right if we're on that same level. So I get 7 from that parentheses there. So I have 6 times 7 minus, parentheses, 1 plus 2 plus 3 plus 4. Anyone who's gone bowling recently knows that that gives you 10. And then divided by 5. All right, so now again, left to right, multiply, divide. 6 times 7, 42. Minus 10 divided by 5 is just 2. 42 minus 2 is 40. That would be my answer right there. Looking at letter F, what do you notice? I notice these fractions. Right? Now, whenever we add or subtract fractions, what do we have to have? Common denominators. So what's going to be the least common multiple of 2, 3, and 4? Well, 2 and 3 is 6, but that doesn't work for 4. Next would be 12. Now that works for all of them. So let's rewrite these fractions with a denominator of 12. So if I change all of these to 12, let's see what we got here. All right, so half of 12 is 6. A third of 12 is 4. A fourth of 12 is 3. So I'm just going to focus on these fractions here. I'm going to simplify this. 6, remember, whenever we add or subtract fractions, we only add or subtract the numerator. The denominator stays 12. So I'm going to have something over 12 here. 6 plus 4 is 10. 10 minus 3 is 7. I'm going to have 7 over 12. That's what 1/2 plus 1/3 minus 1/4 simplifies to. 7 over 12. Now over here, I need to figure out what 4 plus 3 minus 2 minus 1 is. So 4 plus 3 is 7. Minus 2 becomes 5. 5 minus 1 becomes 4. So this is 7/12 times 4. So remember, whenever we multiply fractions, we can rewrite this 4. Oh, excuse that. We can rewrite this 4 as 4 over 1. And then we just multiply across. So 7 times 4 is 28. 12 times 1 is 12. 28 divided by 12. How can we simplify that? We need to look for a common multiple of 28 and 12. Or sorry, a common factor of 28 and 12. So let's think here. 2 will work, but is there anything bigger? I think 4 will also work. So we can factor 4 out of both of these things, right? So 28 divided by 4, 12 divided by 4. This is going to leave me with 7 over 3. And that right there is my answer, 7/3. All right. Go ahead and take a little pause here. Look over our work in E and F. If you have any questions, feel free to raise your hand and ask, and I can help you out individually here. All right. Now let's move on to letter G. So G and H even as well are the format of a very common mathematical formula called the quadratic formula. And we're going to learn a lot about that later this year. But for now, we're just going to practice simplifying. So looking in here, there's a couple important things that we need to know. Where does a radical fall? Radicals are on the same level as exponents. All right, and remember earlier I talked about how some people wanted to change Pemdas because it left some blurred lines. It wasn't entirely clear in the order. This is one of those issues where it doesn't talk about radicals in there. Radicals are on the same level as exponents, but we also have to assume that everything under a radical is in parentheses. So that's where we're going to start. We're going to start simplifying everything under this radical. So I'm going to do -2 plus the square root. Now, 9 squared is 81. So let's do with that first. 5 times 3 times 3. And then all of that is over 2 times 2. All right. Now, next up, I need to do this multiplying here. 5 times 3 times 3. So I'm going to have -2 plus the square root of 81 minus 5 times 3 is 15. 15 times 3 is 45. And I'm going to put all that over 2 times 2. All right. I'm just going to draw an arrow here. So I'm -2 plus the square root 81 minus 45. So let's break this down a little bit. 81 minus 45, so that's 81 minus 40, so that'd give me 41. 41 minus 5 would give me 36 over 2 times 2. Now the square root of 36, what number multiplied by itself gives me 36? And that, of course, is 6. So I'll have negative 2 plus 6 over 2 times 2. Now this is another one like earlier. We have to assume a couple things here. Assume that we need to simplify up top. Imagine all that being in parentheses. So here I need to do negative 2 plus 6. Well, that's the same as 6 minus 2. So that will give me 4 over 2 times 2 is 4. Now any number divided by itself equals 1. So all of that simplifies just down to 1. Very nice. Now, why don't you go ahead and try letter H on your own, and then we'll check that together, okay? So go ahead and take a moment, try letter H on your own. Feel free to pause the video if you need to. All right, let's check in with letter H here. So, letter H, negative 7 plus the square root of 7 squared minus 4 times 1 times 10 all over 2 times 1. Whew. Okay, well, remember, we're assuming, well, we know now, that everything under that radical needs to be simplified first. So let's do that. So we got negative 7 plus the square root of 7 squared is 49 minus, and I'm going to go ahead and combine this here, 4 times 1 is 4, 4 times 10 is 40. We'll put all that over 2 times 1. Now 49 minus 40 is 9, so I'll have negative 7 plus square root of 9 over 2. All right, what is the square root of 9? What number multiplied by itself gives me 9? And of course that answer is 3. So I have negative 7 plus 3 over 2. So negative 7 plus 3 would give me what? Oops, sorry about that. Negative 7 plus 3 gives me negative 4 over 2. Negative 4 divided by 2 gives me negative 2. And that would be my final answer there. Hopefully we got negative 2. If not, go ahead and raise your hand. Let me know, and we'll come over and figure out where we went wrong. Or go ahead and look, see if you can figure out what we did wrong. Now that's going to end our part 1 notes for today. Nice work. Let me know if you have any questions. And if not, go ahead and get working on your part 1 problem set number 1. All right. That concludes Objective 1 Part 1. We'll see you next time.